You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Encryption practices in cloud environments are essential for ensuring that data remains confidential, intact, and secure throughout its lifecycle. Whether data is stored, transmitted, or processed, encryption protects it from unauthorized access. These practices apply to a wide range of components, including the operating system, applications, file systems, storage volumes, and APIs. This credential places encryption within the domains of security, compliance, and identity, recognizing its central role in protecting cloud resources and sensitive information. Applying encryption across all layers of the cloud stack is necessary, because threats can originate from many directions. Access controls may fail, credentials may be compromised, and logs may be intercepted. Encryption ensures that even if an unauthorized user accesses the data, it remains unreadable and unusable. Cloud environments include numerous systems, interfaces, and storage methods, each of which must be protected with the appropriate encryption mechanism. The exam may test how candidates apply encryption practices across multiple infrastructure components. At the operating system level, encryption typically protects the volume that contains system files, applications, and temporary data. Encrypting the OS volume prevents unauthorized access in scenarios where virtual machines are stopped, images are copied, or storage devices are moved. This protection is especially important in cloud environments where infrastructure is easily duplicated. Candidates should be familiar with how to enable host-level encryption for different virtual machine platforms. Disk encryption tools such as BitLocker and Leakcase are commonly used to protect data stored on drives. These tools operate at the block level, ensuring that all data written to disk is automatically encrypted. To be effective, the encryption keys must be stored securely, often using a trusted platform module or an external key management system. Candidates should understand the benefits and limitations of disk encryption, including the performance trade-offs and the importance of securing the key infrastructure. Application-level encryption allows developers to secure sensitive data, such as personally identifiable information or payment records, before it is transmitted or stored. This method encrypts data within the application logic itself, often using libraries or frameworks that support secure algorithms. This approach ensures that encryption is tailored to the context and can protect data end-to-end, regardless of where it is stored. The exam may present a scenario where an application encrypts user information before writing to a database. File system encryption secures individual files or directories, often without requiring changes to the user workflow. This method encrypts data at the file level, making it invisible to unauthorized users even if they can access the storage device. File system encryption often works in conjunction with access control lists and file monitoring systems. This credential includes file-level encryption as a requirement for endpoint and virtual machine security, particularly in regulated environments. Cloud storage encryption is typically applied to block storage, object storage, and file storage services. Providers often offer encryption by default, using either provider-managed keys or customer-managed keys. Block storage encryption protects virtual disks. Object storage encryption secures data in buckets, and file storage encryption protects shared directories. Candidates must know how to select encryption settings during provisioning and how to verify that storage volumes meet organizational policies. Cloud providers often offer default encryption, which applies automatically using their managed keys. Alternatively, organizations can bring their own keys to maintain control over key access and rotation policies. Bring your own key models increase control and may be required for compliance. The certification may test your understanding of the difference between default encryption and customer-managed encryption, especially in scenarios that involve regulatory or contractual requirements. Application programming interfaces and web services must also be encrypted to protect data in transit. Secure APIs use protocols like HTTPS and enforce transport layer security at all endpoints. In addition, APIs must validate certificates to prevent man-in-the-middle attacks. Cloud Plus includes encryption requirements for APIs, including configuration of secure gateways, enforcement of TLS, and handling of certificate validation for public and private interfaces. Tokenization and format-preserving encryption are two additional techniques used to protect data while maintaining system compatibility. Tokenization replaces sensitive data with reference tokens, reducing exposure in storage and transmission. Format-preserving encryption maintains the original data format, making it compatible with legacy systems. Candidates should understand the difference between these methods and when to use them, particularly when working with data that must retain structure for operational or compliance reasons. Backup and archive encryption ensures that snapshots, exports, and long-term storage copies are protected from unauthorized access. Backup encryption should be enforced during both creation and storage, with keys stored separately from the backup media. These measures prevent compromise of archived data during disaster recovery or system restoration. This credential includes secure backup as a core practice and may present scenarios where encrypted snapshots are required by data protection policies. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Key rotation and expiration are essential components of an effective encryption strategy. Encryption keys must be changed on a regular schedule to minimize exposure in case of compromise. Automated rotation helps maintain consistency and reduces the chances of human error. Some platforms offer built-in rotation policies that cycle keys based on time, usage, or specific events. The certification may test when key rotation should occur and how expired or compromised keys must be replaced without disrupting service. Encryption in transit protects data as it moves across internal or external networks. Encryption at rest protects data stored on physical or virtual devices. Both layers must be addressed to ensure complete protection. A system that encrypts data at rest but not in transit remains vulnerable to network interception. This credential includes end-to-end encryption policies that enforce protection from origin to destination. Candidates should be prepared to explain and configure both layers for full coverage. TLS configuration must follow best practices to prevent misuse and ensure integrity. This includes using strong ciphers, disabling outdated protocols like SSL and TLS 1.0, and enforcing certificate validation. Proper TLS configuration also supports forward secrecy, which ensures that past sessions remain secure even if current keys are compromised. The exam may include configuration scenarios where you must verify that TLS is set up correctly to protect cloud services or public APIs. Centralized key management systems store, issue, and control access to encryption keys. These systems include AWS Key Management Service, Azure Key Vault, and HashiCorp Vault. They provide fine-grained access controls, audit logging, and key lifecycle management. Candidates should know how to restrict key access by user or system role, and how to validate that key usage complies with policy. The exam may test which vault tool is used in a given cloud provider and how to apply its settings. Encryption policies must clearly define where encryption is applied, what algorithms are used, how strong the keys must be, and who is allowed to manage them. These policies should be enforced automatically at provisioning time or during image creation. Templates and infrastructure as code tools can include encryption requirements so that all resources begin in a protected state. This credential includes policy enforcement mechanisms and requires candidates to align technical settings with organizational security expectations. Logging of encrypted operations provides an audit trail that proves encryption was applied, remained active, and was not tampered with. Logs should include information about when data was encrypted, who initiated it, and whether any failures occurred. These records are critical for compliance, incident response, and operational transparency. Candidates must understand how to generate, retain, and analyze encryption logs, especially when validating that sensitive data was protected throughout its lifecycle. Encryption, while essential, can affect system performance. Encrypting and decrypting data adds overhead to processors, memory, and storage. Systems that handle high volumes of data may experience slower performance without proper tuning. Hardware acceleration, such as cryptographic coprocessors or dedicated encryption chips, can reduce this impact. Offloading encryption to hardware or proxy services also helps maintain responsiveness. The exam may include scenarios where encryption performance must be balanced with service demands. Compliance requirements often mandate encryption for specific types of data. Standards like PCI DSS require that payment card information is encrypted both at rest and in transit. HIPAA requires protection of personal health information through encryption and access controls. Failure to encrypt such data can result in fines, penalties, or breach notifications. Candidates should know which standards apply in a given scenario and what level of encryption is required to meet those mandates. To summarize, encryption is not a single setting but a multi-layered process that must be applied consistently across all cloud infrastructure. It begins at the host level and extends through file systems, applications, storage services, APIs, and backups. End-to-end protection requires proper configuration, regular key management, and effective policy enforcement. This credential expects candidates to understand encryption deeply and to apply it correctly at every level of the cloud stack. Encryption must also be continuously validated. Even with policies and tools in place, misconfigurations, expired certificates, or outdated protocols can undermine protections. Regular audits, penetration tests, and configuration scans help confirm that encryption remains in place and effective. The certification may test your ability to recognize when encryption has failed, what corrective action is needed, and how to prevent future lapses through better automation or monitoring. Modern cloud architectures require encryption that scales with automation. As workloads grow, encryption must be provisioned alongside other infrastructure elements using code, templates, and orchestration. Static methods are insufficient in dynamic environments. Candidates should be able to define encryption settings in infrastructure as code, assign encryption policies to services automatically, and validate enforcement through monitoring tools. This approach ensures encryption is not an afterthought, but an embedded part of system design. Finally, encryption practices must evolve. Threats change, standards shift, and cryptographic research reveals weaknesses in previously accepted algorithms. Cloud teams must monitor advisories, rotate deprecated algorithms, and adapt to emerging best practices. This credential requires an awareness of algorithm choice, update policies, and forward compatibility. Encryption must remain strong not just today, but over time, as systems, threats, and standards continue to evolve. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.